Hello guys, welcome to week 4. This will be video 1 this week. I'll cover different topics pertaining to angles. In this video, this will be just about what angles are, the tool that we use to measure angles, and the names that we give particular angles. Okay, so first let's talk about what angles are. Okay, angles are just parts of a circle that have been cut out. Okay, there's lots of different ways, and you can even walk around your house and see different angles, maybe in picture frames, on the clock, on your cell phone. There's angles everywhere. Okay, the example that I'm going to start with is a clock. Okay, so if you look, you know that this clock, analog clock, is a full circle. Okay, a full circle is made up of 360 degrees. And when I say degrees, I don't mean temperature. Okay, I'm talking about the unit of measuring angles. Okay, and we've discussed this before in class. Okay, so the circle is made up of 360 degrees. Okay, you'll notice that this clock is cut into some smaller sections using these red lines. Okay, and if I count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. So what they've done here is they've taken that 360 degrees total that make up the full circle, and we've divided it into 12 equal sections. Here's one section. Okay, this is what I'm talking about. Okay, each one of those is a section. Okay, well, when you divide 360 divided by 12, that equals 30. That means that each one of these little sections, if we're talking about angles, not time, we're talking about angles, each one of those sections would be worth 30 degrees. And that's what they've pointed out here. Okay, so if I go around and I add up all these 30s together, or if I were to use the 4th grade skill and multiply 30 times 12, because there are 12 30s, that would give me that 360 degrees. Okay, so now let's talk about a quarter of an hour, a fourth of an hour. That would be this. Okay, a fourth of an hour is 15 minutes, but if I'm talking angles, let's figure out how many degrees that would be. Well, I have 30 for each section, and there are 3 sections. That's 30, 60, 90 degrees. That's 1/4 of an hour. Let's do this fourth. Okay, that's another 3 sections. 1, 2, 3, which is 30, 60, 90 degrees. Another 90 degrees. Okay, now let's take care of the next one, the next quarter of an hour. Okay, I'm gonna round this around. And again, I have 30, 60, 90 degrees in that quarter of an hour. And then let's follow it up here with the last quarter, which is another 90 degrees. Okay, so if I were to add 90 plus 90 plus 90 plus 90, or if I multiplied 90 times 4, that would give me that full 360 degrees. Okay, now that 90 degree angle is the easiest one to spot. Okay, that's what we call a right angle. Okay, that's the one that makes the little chair right here. You can put the little box right there because that means this is a right angle. Okay, all right, another way to show a circle that is cut up into angles. I'm gonna have to fold my paper here so you can see. Would be a pizza. Okay, now we all know that pizzas can be cut into different sizes. We learned all of that back when we learned fractions. Okay, this particular pizza is cut into 8 parts. Okay, so again, a circle is made up of 360 degrees. But this time, instead of cutting it into 12 parts like we did the clock, I'm going to cut it into 8 parts, or divide it into 8 equal parts, okay? When I do that, that equals 45, okay? So each slice of pizza has a measure of 45 degrees. Bear with me while I go around. Okay. So on this pizza, when you eat one slice of this pizza, that represents 45 degrees of a full circle, okay? That's this angle right here, okay? That would be angle ADB. And here's where I'm coming up with that name. This is point A, this is point D, this is point B. Okay, this is the vertex where those two rays come together. That vertex always has to be the middle letter. Okay, so to give this angle a name, we name it ADB. Okay, it could also be BDA. It can work backwards that way. So angle ADB is equal to 45 degrees. Okay, but what about this angle right here? Okay, that angle is a much larger angle. That angle, we'll name it angle ADC, or it could be CDA, either way. Okay, so you can see that this angle right here is more than just one slice of pizza. We have 1, 2, 3 slices of pizza that make this angle. So I need 3 of those 45s, okay? Well, if you're good with those numbers and number flexibility, you know that 45 and 45 together makes that 90-degree angle, okay? Then when you add on an extra 45, that gives you 135. So you could add 45 plus 45 plus 45, or use those 4th grade math skills and multiply 45 times 3. 5 times 3 is 15. Carry the 1. 3 times 4 is 12. Plus 1 is 13. That will give you that 135. So angle ADC has a measure of 135 degrees. Okay. So what we've just done with these two models is we've shown how angles will cut apart circles into equal groups. Okay, but when we're talking angles, the angles may not always be equal to each other. Okay, here they were. Each piece was the same size. Okay, but we need a tool to help us to measure if they aren't all the same size. Okay, so the tool that we use, and not just in school, but engineers, architects use this tool regularly whenever they are measuring angles, when they're, generating blueprints and things like that. We use a protractor, okay? And it's a plastic tool, and I apologize, I don't have one here with me. They're up at the school, but it looks like this, and they're generally clear plastic so you can see through them to the angle underneath the page, okay? The reason there is a whole protractor like this that you can buy, but you really don't need that. You only need half of the circle to measure your angles, okay? So this right here is your protractor, okay? I'm gonna label a couple of things for you on here. This line right here, we call this the 0 line, okay? That's the 0 line, okay? 0 line right there. All right, now, you'll notice that there are 2 sets of numbers on this protractor. Okay, it starts at 0 on this side at the top and goes all the way around to 180 degrees on this side. Okay, then you'll notice on the inside, we start at 180 on this side and we go to 0, so it's backwards. Okay, the reason that the protractor is made that way is because not all angles are facing the same direction. Okay, so if you look down here, okay, you'll see that this angle is opened to the left. Okay, it's open to the left. Okay, so in this case, we're going to be using the outside numbers, okay? If it's open to the right, as is the case with this one, you're going to use the inside numbers, okay? So let's start by labeling all the parts that are on this protractor. We have our 0 line down here. Okay, this right here with the arrow on the end and the end point is called a ray. This is another ray right here. Okay, an angle is the measure of degrees between those two rays. Okay, now the point where those two rays come together is called the vertex. This point right here where they meet and come together is called the vertex. Okay. All right, so down at the bottom of this page, they're showing us which set of numbers to use. Okay. So on the left, it says use the top numbers if one ray passes through the 0 on the left. Okay. What that means is the angle is opened up to the left. Okay, and a protractor is really just a number line that's curved. Okay, so if you were to stretch it out, it would be just like a number line. Okay, except it's got two sets of numbers. The outside set of numbers is for when the angle is open to the left. Okay, now on the right, we have an angle that is opened up to the right. So we use the bottom set of numbers if one ray passes through the 0 on the right. Okay, that's this 0 right here. Okay, so when your angle is open to the left, you're using the outside numbers. When it's open to the right, you're using the bottom numbers. Okay, that's going to take us into the next page that we're going to work on. Naming angles. Okay, an angle is the measure of space between two rays. Okay, all right, so there are three different main types of angles that we use. They're missing one, and I'll talk about that one in a minute. Okay, an acute angle is less than 90 degrees. Okay, so they've used this dotted line to show you what 90 degrees is. And the ray that they're using, you can see, is closed less than 90 degrees. Okay, a right angle is just right. Okay, that's the one that makes like a chair. Okay, where you can make the square in the center. Okay, that's exactly 90 degrees. Now, an obtuse angle is greater than 90 degrees, but less than 180, okay? And this is the one I was referring to a minute ago that's missing, the 180 degree angle. That is a straight angle, which would be a straight line, okay? So an obtuse angle would be greater than 90, and they've showed you this 90 degree angle right here, and they're showing you how your angle is opened up past that 90 degrees, okay? That is an obtuse angle, okay? All right, now we've got a protractor here, and the question says, what is the measure of this angle? Okay, well, let's think back to the page that we just did, and let's look at this angle. Okay, you can see that that angle is open to the right. So if you think back to the last worksheet we did, if it's open to the right, we're using the inside numbers. Okay, all right, so over here, oh, let's fill in this bottom or inside numbers. Okay. All right, so we have one ray that's on 0, and then our other ray, and if you think about this, if you look at this angle, you can tell that that's an obtuse angle, and obtuse angles are greater than 90. So if you're looking at this, only the inside numbers are greater than 90. The outside numbers, 30 and 40, are not greater than 90. So I know I cannot be using those numbers. I have to be using the inside numbers. That's another way you can tell which set of numbers to use, is just look at the numbers and look at that angle, and that'll help you, okay? So this ray is halfway between 140 and 150, okay? So it's halfway between 140 and 150, okay? So that means that this angle has to be 145 degrees, okay? Making this an obtuse angle, okay? All right, so let's practice with the ones at the bottom. All right, it says measure each angle below and record whether you use the top numbers or the bottom numbers on the protractor, and name each type of angle, acute, right, or obtuse. Okay, well, on this one, my angle is open to the left, meaning this ray runs through the 0 that's on the left. So we're going to use the outside numbers. Another way that I can tell, this angle appears to be an obtuse angle. It's very large. Here's 90 degrees, so we can use that as kind of a benchmark. There's 90. So I can see that this is open past that. So I need an obtuse angle, which is greater than 90. So if I look out here, okay, I know I'm not going to use the inside numbers because they're not greater than 90. I'm using these numbers right here, okay? All right, so I used the outside, okay, or top is what they're using, the top numbers, okay, and I'm halfway between 160 and 170, so that means that this angle is going to be obtuse, and it is 165 degrees, because 165 is halfway between 160 and 170. Okay, let's do the one below it. Okay, again, this one is open to the left. Okay, we have the 0 running, this ray running through the 0 on the left, so we're using the outside numbers. Okay, this ray runs straight up to 90 degrees. Okay, so that means that this angle is 90 degrees and is a right angle. Okay. Another way you can check for sure is you know that they're counting by tens here. So you could count by tens and that would get you all the way to 90 degrees. Okay. All right, to the right. This one is also open to the left, so we're going to be using the top numbers. Okay. I have one of my rays running through the 0 that's on the left. Okay. Now, I can also tell that this is a very small angle. It's less than 90. Here's 90, okay? That means it's an acute angle, okay? So I need numbers that are less than 90. Well, 10 and 20 are not less than 90. They are less than 90. These numbers are greater than 90, okay? So I don't want to use these inside numbers because they're greater than 90. I want numbers that are less than 90. Okay, so we're starting at 0 here, and then out here we are halfway between 20 and 30. Halfway between 20 and 30 would be 25, so that's 25 degrees, and this would be an acute angle. Okay, all right, and the last one. Okay, the last one is open to the right. Okay, that means that this bottom ray is passing through the 0 that's on the right. So instead of using the top numbers, we're going to use the bottom numbers this time. Okay. You can also tell that this is a very large angle. It would be obtuse. Okay, so we need numbers that are greater than 90. Okay, I need numbers that are greater than 90. So if I look out here where this other ray is pointing, okay, these numbers over here are not greater than 90. These numbers are, okay? And this ray is pointing right in the middle between 170 and 180, which would be 175 degrees, making this one an obtuse angle. Okay, that concludes video 1. The next video we're going to cover will be some more measuring angles, but a little more difficult angles, so stay tuned for that.